All right, so now evaluating logarithms, there's several ways you could do this, okay? And I'm going to show you that. You're going to learn more as you go, but what they're wanting you to do here, these are kind of simple logarithms. And so you're going to kind of think, you want to convert these into exponential form. Okay, and so notice that there's no equal to, so you're going to make it equal to x actually, and this is what you're going to solve for. So the first step is to convert it to exponential form. So remember, my base is 10, and then 10 raised to the x power equals this value of 100. And then so you ask yourself, 10 to what power gives you 100? 10 to the second power. Okay, so you could ask yourself, 10 to what power equals 100? So 10 to the second power. Okay, so these are simple ones. You're going to get nice answers. All right, this one's a little different. Log of 5 of 125, 1 divided by 125. And so I'm going to put equals some value x. And then I'm going to do 5 as their base to the power of x equals 1 divided by 125. Okay. Now, another way to do this is you could do what we call the one-to-one property. And so what's the one-to-one property? We could, first off, I'm going to rewrite this fraction as this value has an exponent of 1 on the bottom. I'm going to rewrite this as 125 to the negative 1 power. Okay, so 1 divided by 125 is the same thing as 125 to the negative 1 power. Then I'm going to ask myself, this is called using the one-to-one property, what equals 125 but has a base of 5? Okay, what am I talking about? Okay, I'll explain. So, like, what could I give? Like, if I do 5 squared, that's 25. That's not going to work. What if I do 5 cubed? 5 cubed is 125. So 125, 5 cubed equals 125. 5 cubed equals 125. And so if 125 is the negative 1, this would be 5 to the x equals 5 cubed times negative 1. So 5 to the x equals 5 to the negative third. And so at this point, notice this called this one-to-one property. If their base is the same, you just set the exponent equal to the power here. So therefore, x equals negative 3. Okay. Next, log base 36 of 6 equals x. So I'm going to rewrite this. So 36 to some power equals 6. So what I need to do is let's try to do the one-to-one property. 36, how could I express 36 to where it has it has a base of 6? 36 and that 6 squared, so 6 squared times x equals 6. And notice the bases are the same now. So then I could say this is 6 to 1. So then I could say 2x equals 1. Divide by 2, x equals 1/2. Okay. Log base 3 of the 7th root of 3, we'll talk about this. So it equals x. So 3 to the power of x equals the 7th root of 3. Now let's talk about what the 7th root of 3 equals, okay? This 3 has an exponent of 1, so this is going to have what we call a rational exponent. So this is equal to 3, is going to be my base. The exponent of 3 is going to be my numerator. The root back here is the denominator of the fraction. So the 7th root of 3 is equal to 3 to the 1/7. So 3 to the x equals 3 to the 1/7. You see the bases are the same, so I can just set the exponents equal to each other. X equals 1/7. Now you can cheat in your calculator on this. You can go to math to check your answers, math log base. So math option, I think it was B, log base. And so you go to log 10, 100. So you see it's going to be 2. Math option A, log base. 5 of 1 divided by 125. Negative 3, see that? Math, log base, 36, 6 is equal to 0.5, which is 1/2. Math enter 1/2. And then here you go, math, log base. This one, how you express this one is you've got to go to math option 5. to put a root in there that's above 3. So I'll give you 1/7. Okay. That was a ways checker.